Good afternoon, everybody. I'm Addison Snell with Intersect 360 Research, and welcome to the fishbowl. This is a fun panel format that we started last year for the first time, and I really have to thank the ISC organizing committee, and especially Eric Schnepp, who helped organize it this year, and John Schalf, who helped create the whole idea last year for the first time. I was very nervous when we did this for the first time last year, and was relieved that we had a ton of fun with it, and I'm glad that we have the format back this year. For those of you not familiar with it, our topic today is discussing the future of HPC and AI, particularly focused on separating myths from reality in a lot of different categories, and thus the title, Everything You Think You Know Is Wrong. As the moderator, it's my job to lead a panel of 3 forward thinkers, and you can see them here, 1, 2, 3. The reason there's a blank chair here is because this is designed to be an interactive panel. I'm delighted to start by, I knocked over a water glass, delighted to start by introducing Kathy Yelick, who's the Vice Chancellor for Research and the Robert S. Pepper Distinguished Professor for EECS at UC Berkeley, and who gave our morning conference keynote this morning, Beyond Exascale Computing. Thank you, Kathy. As well as Rosa, Badia, who is the manager of the Workflows and Distributed Computing Research Group at Barcelona Supercomputing Center. And she, with John Schalf, is going to be giving a talk tomorrow on reinventing HPC with specialized architectures and new applications workflows. Thank you, Rosa. The way this is going to work is, for every panel that you've ever sat at and thought, well, that's not what I would say, well, now's your chance. What we're going to do is we've got an empty chair here now. I'll ask for a volunteer who will join the panel. And then throughout the panel, every 8 minutes, I'm going to let someone go and replace them with a willing volunteer from the audience. When you come up, I've already introduced these two. Please introduce yourself, say what who you are, what your role is, where you work, and kindly disagree with something that you've already heard. That's the way this is going to work. It'll keep the panel fresh throughout the hour and 15 minutes we'll be here. So, do I have a volunteer who'd like to be our third panelist to start out? All right, come on up. Now, luckily, you don't have to disagree with anything, so you grab the first shot. But please introduce yourself and your role and where you're from.
So I am from Frankfurt. I'm working my role is called cluster administrator. I'm taking care about our cluster. And my topic is that I don't believe that the users will improve their own code, even if you show them that the code works in a shitty way. So, and even you come up with monitoring and tell them everything, how to improve, and I disagree, even if you show them, they don't improve their code because the problem is inherited in itself, how university works, how contracts are established, how contracts are finished after 2 years, and the knowledge goes away and somebody new comes in.
All right, it's a panel. You don't get to give a whole presentation. I'm sorry, what was your name again?
Marco.
Marco, thank you very much for joining. And I'm actually going to build on that because it gets to, Kathy, some of what you were talking about before, because you're talking about not only where we are today, but the path toward beyond exascale and toward zettascale. And if people aren't going to be improving their codes, that brings up a question, which would have more utility? Are we better off with a zettascale system or 1,000 exascale systems? And how do you defend the pursuit of higher levels of performance? Why don't you start?
Well, I think that, the real question you're asking there is how do we defend the integrated system, right, at scale? And so, and the answer is because there are enormous problems that we want to solve that can only be solved on a single integrated system. But that said, I will say that we should not dedicate those large-scale systems to only solving the biggest systems. I think we can do a tremendous amount of science by being able to run them, as 1,000 exascale systems, if we've got a zettascale system or whatever we want. I also would like to avoid, if possible, although I think this is a losing battle, to focus on a zettascale as opposed to focusing on 1,000 times faster in various ways than today's exascale systems.
Well said. Rosa, do you agree?
Well, I agree, but I'd like to give a complementary answer. Also the approach, I think, following a bit what Marco was saying, in Europe at least, we have the POP3 Center of Excellence. There's a project that's looking at the codes and making suggestions and hoping that these are applied, or we help them to apply it. So this will be on improving the application. But the other thing is things we try to do at runtime. So with malleability or with the runtimes dynamically try to improve the efficiency of the codes or kill computations that not needed anymore or creating new things. So I think this is a way also of improving the efficiency of the systems, no? And also with, for example, for another topic would be about energy consumed. We can also help much more the end users because traditionally, if a code is written, also will consume more because probably will be slower. So if you help with also monitoring the energy, and you can make also suggestions to improve the code base also in the energy that is consumed. No?
All right, so go back to Kathy for a second, because you got a complimentary
can I
answer
add
there.
something?
Yeah,
to this?
please.
I think that, building on what Mark said, if you think that the traditional HPC community doesn't care about the performance codes, you should talk to the AI community. Because other than, I'm sure, a few sort of, performance engineers working at the kind of bottom of that stack, most of them have, they haven't thought at all about the fact that they're consuming so much computing resource that they really do need to worry about the efficiency. So.
All right, Marco, now get in there. You've heard what they have to say. Do you agree or disagree?
I heard the arguments, but the real point is, so I'm in the business over several years, and we come up with monitoring. And as I said, the problem is inherited in the structure, especially in Germany. I cannot talk about other countries, how they work in this field.
But where would you get any new ideas if not for the students at the universities?
Well, so especially in Germany, there is this statement that research is free. You cannot push somebody to improve their code, and usually. I shouldn't say that, but they don't give a shit in improving the codes. They just proceed. They circumvent the problem. New PhD students come in, inherited some code he don't understand or she don't understand, and she or he must drop her pants and say, "Hey, I don't understand the whole topic," and that is not usually what they do.
So come back to the top level question then. Are you arguing that we shouldn't be making the computers faster, or that we should because it's the only way the code gets better?
We should do the more monitoring, and we should find, in the sake of environment, a way to push these people to get up and do their work in the proper way.
Yeah, that sounds like you're trying to control people that you don't have control over.
No, it's not control. But, well, if you talk to a chemistry person.
Chemistry?
Yes, and biologists, they are not computer scientists. So they can work with a Gauss program or with a special software.
I'll push back on that one. I've been hearing that same argument for 30 years, though, and we still seem to improve these codes generation after generation.
Yeah, that might be
not Gaussian.
true.
Maybe not Gaussian.
Maybe not Gaussian. Okay, fair enough. Rosa, they've been going back and forth. What do you have to say to these two?
Well, I was thinking on that I understand the problem you're describing, but I think the solution is having multidisciplinary groups, and I think we should work to push the people to work with multidisciplinary teams where you have an expert on programming, developing, and because you're talking about more basic research in the university, maybe. Also, there are a lot of work on now educating on better software development. I think there's a nice tutorial typically at SC, on how to maintain the software, how to build everything. And I think we should also push the scientists towards this, not only in saying, oh, this is ill-developed, whatever. No, look into all these techniques that you can use, and
Personally,
takes
I
to go
think
into
we
things.
have no recognition problem, we have a solution problem. Usually we know what the problems is, but we came up with, we need more money, we need more personnel. So if you looking carefully around over this conference, you might figure out the average age is around 40. So here is a lack of people who should supervise the software, who
computed
should
the average,
improve it.
the average dynamically. You
This
compute
just
it.
proves that
I'm
if I
much
get
stronger.
Marco to volunteer, you don't need a moderator anymore. Kathy, by the time I lose you here, though, I want to get a different view on this, though, because we're talking about these very large systems. Are you concerned about the increasing gap between the most powerful systems and everything else? Is there some sort of inequality there, or is that not a concern?
Well, I'm concerned about the inability to have that. I think I talked earlier about the sort of movement from things like Beowulf clusters, right? That widespread access to cluster computing has been something that's also fed into the high end. And if things go in a more specialized direction, I'm really worried that we'll lose that the kind of cluster parallel computing will only be at the centers that have it, and that the universities may not, and then it'll be cloud systems, I guess, and HPC systems. And so I think that we need to make sure that people have access to this. If they become very specialized, I'm not sure that universities will buy them.
All right, Kathy, you already got to give a whole talk. You're done. Thank you very much, Kathy. And we'll need to fill this chair. I should have been said, all right, Stephan, why don't you come up? And if you want to volunteer, and I'm not seeing you because these are bright lights, Eric Schnepp there in the aisle, if you get his attention, he will help you get up on stage. Stephan, for everyone else, please say who you are, where you work, and give a different view to something you've already heard.
So, hi, I'm Stephan Schenk. I'm with BASF. The chemical company was the former logo. And I'm a chemist by training and did a PhD in quantum chemistry, so you understand why I should have stood up here. So I tend to disagree from my academic time, although it's more than a decade ago, we did optimize the code to run. And also in the company, we definitely look at code that performs well. And I know
Now, that
groups
can't
in
be
Germany,
true. I just heard that you don't know anything about optimizing code.
Yes, we outsource that, but we do care, nevertheless.
Okay. I liked something that Rosa said that I wanted to come back to, is this idea of cross-disciplinary teams in terms of putting that together. And that's a good place for you to jump in on. Does that occur within BASF? And if so, how essential is it? I mean, you're talking about chemistry, right? Do you still need a cross-discipline team?
Absolutely. So this was when I joined the company like 15 years ago, this was for me an eye-opener that all the teams were interdisciplinary. So you had chemists, you had material scientists in there, and that was kind of the key of success. And we also have a LAMPS developer in the team, and yeah, they know their stuff around, and they do also some optimization. So at least I would say we do care about the performance, yeah? And it's all interdisciplinary. Chemists are no good programmers. So,
Marco, you got a leading chemistry company coming back after some of your comments. You stand by what you said?
Maybe the salary is much better compared to university, and I
No
guess
comment.
there is more incentive to improve the code. So where university, well, it might work, it might not work, nobody cares. So even if the code runs in a shitty way and they get additional computational time they shouldn't get, they have some B connections to somebody, and in the end they usually get their additional computational time. So I see no really incentive to improve the code. I see the main goal, I admit I see the great goal, but there's a long way towards this goal.
may I change shape, Addison? Put on another hat.
Sure.
So I know from the Yelick Supercomputing Center, from the discussions we had in the Scientific Council, that absolutely you care about performance. So it's in Germany, being German myself, I think it makes a large difference on which centers you're working at. And I was doing my PhD in a small university, computational-wise small university, Jena, we didn't care about performance, but then I moved to ETH, and we definitely cared about performance. So it really depends where you are. And I see the problem, but I don't think that it's ubiquitous.
I want to bring in a different dimension of this and start with Rosa on it, because something that you're going to be talking about tomorrow, not to give away a whole lot of your talk, but you've got in your premise that we're talking about combining HPC with analytics and AI, and we're talking about trying to not only make applications scale more, but now you've got these multiple types of applications. How do we make it easier to develop scalable applications that can combine these different types of computing, HPC, analytics, AI?
Thank you. It's on Wednesday, but thank you.
Oh, I'm sorry, Wednesday. I don't know what day it is anymore. I'm still jet lagged.
I don't want tomorrow people to come and get disappointed
Wednesday,
because John
excuse
and
me.
I are not speaking. Well, this was a series of workshops that we were meeting internationally about the conversions of HPC with AI and also big data, the BDEC. And there was a lot of discussion, and one of the topics that we were discussing is this, how you program applications that combine everything, because so we have in one side that the systems are growing in scale and heterogeneity and everything, but also the applications providers every time want to do things more complicated because they realize that they have the underlying performance so they can do better jobs, no? But then if you want to combine the traditional simulation modeling with AI models or things like this, of course you need to converge on some programming models because the software stacks, this also was analyzed by Dan Reed and Jack, I think was, the software stacks are different, no? So in our case, we've been doing some workflows where the orchestrator is based on Python, no? Python, I mean, people say, you don't get performance in Python. No, I don't get performance in Python, but I'm only orchestrating with Python or whatever orchestrating script or language you want to use, no? But then you can use Python to integrate the different MPI codes with AI and so on, no? And then this is also very nice because then this fits naturally very well into new heterogeneous systems. No? At BSc, the new cluster, Storm 5, has some general purpose partition, but has accelerated partitions. No? So then you can map part of your computation, the more at HPC, maybe you want to run it in a regular general purpose, maybe you can run some AI on GPU and things like this. No? So a little bit, this is what we've been doing. I don't know if I answered the actual question.
No, I think you did, but if people want to learn more, Wednesday, what's the exact time of your talk with John?
5:15, John will start and then it will continue.
Wednesday at 5:15, people can find it on the agenda. Okay, you're going to give another talk, so you're done. You can leave your microphone. Thank you, Rosa. Do we have another panelist? Eric, do you want to pick someone? Go ahead. Come on up. And please feel free to give me your name, your role, where you work, and then disagree with something.
Yeah, so I'm Jeff Hammond from NVIDIA. I'm a quantum chemist, and I want to disagree because I've been optimizing and parallelizing codes for almost 20 years.
I didn't know this was going to be a chemistry panel, but this is fun so far.
But actually, what I want to comment on is education and incentives.
Okay.
Because I started grad school, I was a MATLAB pencil and paper theorist. I got a DOE fellowship, and I started attending NSF and DOE-sponsored workshops at NCSA and NERSC. I've been a NERSC user now for almost 20 years. I've used Seaborg. I was a NERSC user when Horst was in charge. And I've received the professional incentives that made me parallelize the hell out of codes, optimize the hell out of codes. And I would say, if there's a problem with German grad students, it's a problem with the German funding system, and they should fix it.
All right, well,
it's not a problem with HPC.
Jump on what Rosa was just talking about, though. Now we've got to combine traditional HPC modeling and simulation with analytics and AI approaches. Does the same principle apply, or what do we need to do same or different?
It's going to be even better.
Use the microphone.
Yeah, it's going to be even better, actually, because the starting point for the codes is so much worse. Right? Quantum chemistry has 50 years of people, my heroes doing all this work on parallelizing for craze and everything else. I mean, the bioinformatics people start with like Java code that runs on somebody's laptop. And, now we have the Berkeley folks doing Miraculous and everything else to parallelize genomics. There's the incentive to do good things with codes is huge. So when I was a grad student, the best code in the world could do benzene on one computer. And I wrote a parallel code, and I ran buckyball. And so some of you may know that quantum chemistry is not linear scaling, right? From 6 to 60 carbons is a million times harder problem. And I didn't worry about getting scooped anymore because I had a supercomputer and the only code in the world that could use it. So I got papers like crazy. I just had to go press return and get the biggest simulation in the world. So the data scientists and everybody out there, optimize your code, and it's just a paper printing machine.
Stephan, I see you there, but I'm going to ask Marco first because you've been hearing about, all right, here's what we need to do to now update these applications with the different dimensions. What do you were just saying no one's going to do it. Now it's got harder, right?
No, I think personally it's connected also with a social aspect from my perspective. So I recognized for myself that the behavior of today's PhD students is different compared to PhD students 20 years ago. We are in a kind of loop, it's my personal perception, we're living faster. People have problems to concentrate even on a topic. They're pulling out their smartphones, they're writing all the stuff, they have really a lack of attendance. And in the 20 years ago or 10 years ago, I would say you have to overcome more problems, not only the problem in your PhD physics, PhD topic, also with writing it down, come over with, I forgot the name when you have to, not Word, the other one in scientific writing, not Linux, LaTeX. Writing down in LaTeX, you have to learn it first, and you have to solve very different problems. And when I see PhD students today, they come in, say, okay, give me the machine, give me the input, let me run the machine, take out the statistics I want to write down my dissertation, and hand it over, and I want to be done in 2 years.
Okay. I love this
and
panel.
so how can you expect that they try to optimize their code?
Stephan, this is so surreal that we get to do this on this panel. I didn't expect that what we would start with is 3 different people at least telling you that you don't understand how chemistry works. So
kind of, isn't it? So
go ahead.
Jeff, thank you for all the optimization because I used the code in my academic time back then. I really disagree in I think that it's kind of a local problem. I've experienced this in German universities, but I try to believe that the glass is 50% full, and I've seen so many talented people out there, and I've seen so much progress that I don't think that we have a general problem. So. And if I look at my kids, my daughter is 16, and she's now highly motivated. Don't ask me what this switch was that was switching in her head, but we have really talented people out there that are willing to learn, and this is what they are going to discriminate between being successful in your life or not. So I really disagree with the black situation that you're describing, no?
All right, so
it's not a generalization.
I'm going to cut this off because what's clear to me is we could have an entire panel on what's wrong with education and kids these days. But I think we need to pull it more back into the role of the HPC community, other than saying they're all getting educated wrong. Now, when we look at something, Jeff, you were bringing up around these optimizations, one of my observations as an analyst is that we see a lot of industry consortia that are developing software stacks, but then there's also a question of, is it truly an industry-wide consortium, or is this now I'm recruiting allies into my camp versus a different industry consortium camp versus a different one? Where is this really an open community effort and we're all trying to help each other, or is this still competition, and does that matter?
I'm going to try to be real careful because of where I worked.
Well, yeah, I asked you on purpose.
So I think that, yes, it can be a distraction to worry about some of these sort of partial or, as you say, sort of constructed, coalitions of the willing. But I would say the one thing that I think almost all the vendors agree on is the ISO language foundations. Of course, God's true language, Fortran, which will of course outlive us all. But also this.
We had spirited discussions about Fortran last year. We'll get Michelle Whelan back up here. She was in.
But I think at least certainly it's an NVIDIA perspective that all roads eventually lead to ISO, and because that's the one that's going to work everywhere, and that's where it's certainly where we're committed. Obviously, other vendors do other things, but they are also, nobody's trying to say that C++ and Fortran don't matter. And I think, if as an end user, yes, there's a point of being part of the fun transition points, but if you really only want to just do science and not think too hard about what's going to happen here and there and going to change in 5 years, the ISO languages, C++ and Fortran, and of course the ecosystem, Cocos is, for example, a fantastic ecosystem that's, vendor agnostic, built on C++, and, all the vendors support it. It works everywhere, and it's a great way, Cocos evolves into ISO C++.
5 points for mentioning Cocos. I like that one. Marco, your view on the industry consortium question. Industry consortia, would you prefer that it's one software stack that everybody uses, it's the same, or do you like, here we're going to specialize on one architecture versus another?
I like kind of using standards, but if there is a lack of a new method, I tend to develop it on the own, so I can accept two kinds of worlds. So I like the one world with the standards, but if it's necessary to build up something new, it's necessary.
All right, suddenly you agree with everybody. Sit down. Thank you, Marco. Eric, Alexandra is coming up? All right. Well, Eric said you are, so I guess you are. What do you think? Is this fun? This is a blast for me. Okay, please introduce yourself and where you work, and kindly disagree with something you already heard.
Full disclosure, I'm not a quantum chemist, but some of my colleagues are, so I have to take the stage. So, hi, I'm Alexandra Kourfali. I work at HPC. I'm a program manager. I take care of the CHIPS projects, like the European Processor Initiative, and my background is reconfigurable computing, a sprinkle of reliability, and things like that.
Okay.
Yes, and with what I disagree.
Yeah.
With many things, so let's scale it back a bit to the education. So I wanted to highlight that at HPC we built a whole, let's say, a pyramid of training schemes, both for students and young professionals and startups and SMEs, to train them on HPC, and if they are already HPC users and they want to use AI, we'll make also support networks for AI models, specifically for HPC users. So we are working on it. Of course, there is some, let's say, knowledge gap, but still we are building a whole infrastructure around it, especially the NCCs. So we have the national competence centers in all countries established, so we are dealing with training of young people.
All right, you brought up AI, and you've got NVIDIA sitting to your right, and I'm going to credit Kristen Merritt with this upcoming question. Kristen Merritt from Alsace Flight, who's also with Women in HPC. To what extent do you think AI is a disruptor which changes or augments HPC versus a displacer that replaces HPC?
For me, or for you? Okay. No, please start. I can disagree later. No, please start.
Well, I called on Alexandra. We'll get to you. We know what you think, NVIDIA.
I don't do AI.
Oh.
Not really.
Alexandra, what do you think? Disruptor or displacer?
It's a disruptor. I mean, it's an enabler. So AI is cool, is the cool kid in the block. And HPC is considered something more traditional, let's say. So AI comes also with young people, young minds, and funding. So, and a lot of the underlying techniques can actually benefit AI. So I think that when we have to do AI, we have to boost HPC, and then we have to design better hardware as well. So everybody
Stephan,
wins.
how's it going at BASF? Is it augmenting or disrupting or displacing?
It's disrupting, since many of the workflows in the lab will be different once you have AI, but this is another panel discussion. One example I learned like 3 weeks ago, and coming back to chemistry, is that AI is doing great things. So I did my PhD 20 years ago, which means I can do my PhD now on a mobile phone in 3 months from compute power. What I learned 3 weeks ago from AI, from Stephan Grimme's work, is I could do this also in 3 hours if I just used the right algorithms. And this was based on AI augmented there. So from 3.5 years to 3 hours, I think that's significant. So we need kind of both hardware and algorithms that are going hand in hand.
Jeff, you appropriately hit back at me. I don't know what you think. You should answer the question.
So I think it's all of the above. So the first thing is the AI people I work with who build AI physical models are consumers of HPC simulation data. They need training data that doesn't suck.
Absolutely.
GIGO, okay? So they want me to make better computational chemistry codes so they can apply learning to them, okay? There's also the fact that AI is just an HPC workload. Of course, as we said this morning, it's been linear algebra all along. They're doing tensor contractions, one of my favorite things from quantum many-body theory. They're using all the same tensor methods, all the same MPI stuff. It's the people who work on nickel. It's just, makes us a lot of money as a back end for PyTorch. The guy who is a technical lead of nickel is a 20-year MPI guy. And he basically says, nickel's an opportunity for me to do it right because I don't have a standards body to tell me what I can and can't do. So it's also a disruptor, because if we ever get ChatGPT to do something interesting with code development or all the copilots and all that stuff, it's a disruptor in the same way that compilers disrupted assembly language programmers. It would make programmers do more in less time. And that's great. Like, nothing about AI is bad for HPC. It's actually, all of it is good. It's cooperative and it's cyclical.
Stephan, you were nodding along. You're not throwing Jeff off the island for that response?
So if I have to agree, then I have to agree. It's kind of bad for the
fine.
panel, but I can't disagree. Because all you said is
Alexander,
right.
you said you were going to disagree with everything. Did Jeff nail it?
I'm so sorry, I have to agree.
All right. Well, then let's ask a different form of the question then, because I promised we would get to things that are, what's myth, what's reality. And one of the things that we hear people talking about is everything's going to GPUs. Let's challenge that assumption. Is that true? How necessary are they? Is the future really GPUs? Or I could put it differently and say, what are the limits to GPUs or other accelerators, whether it's HPC, AI, or something else? Alexandra, start with that.
What I have been discussing recently, because I also believe that the future, especially for AIs, is just GPU all the way through. But there are apparently some legacy codes that cannot be optimized for GPU. This is especially the case for some traditional codes, like for nuclear, that it is considered almost impossible to be optimized for GPU. So CPUs are still here, and there's still some work for them.
Jeff, what do you think of that?
Well, we're a CPU company now too, so
I
obviously
understand.
we see some value in the system level optimization, right? That there are fundamental bottlenecks that if you don't have algorithmic parallelism, you either need to come up with algorithmic parallelism, which might be a mathematical problem that nobody knows the answer to, or you need to have a latency optimized processor, which is why we have a cool CPU.
All right, I'll end with Stephan, but I'll repeat the very specific question. What's the limit for GPUs or other accelerators for HPC and AI? Or is there an area where they don't apply?
So for us, we are still running our simulations on CPUs because if either there's no support for GPUs or it's not fast enough that it warrants to buy a GPU, so it's waste of money. And the software that is around has not the necessary physics implemented. So you can do extremely fast simulations, but you could also roll a dice, which is even faster, and you get the same quality. Depends on what you're doing. Might be good in academia to roll the dice, but if you want to sell something afterwards, like we want to do, you better not roll the dice. So it really depends on what you're doing there.
Well, what do you know anyway? You only had the first petascale system in all of chemical engineering. So get off the stage. Thank you very much. Next volunteer, come on up. Please introduce yourself. Where are you from?
Right, so I'm Marek. I'm from the University of Cambridge's Faculty of Mathematics, and I'm basically the technical faculty HPC manager. We have got a fairly small HPC system, which, in contrast to the central IT of the university, which is meant primarily as a development/testbed platform. So we try to go for not too big, not too powerful, but more heterogeneous.
And I'm sorry, I missed your name. What was it again? Marek. Thank you very much for joining the panel. What would you like to disagree with?
Let me... Okay, I will go back to the kids these days thing for a moment.
This would...
Yeah.
Take a note for a future panel, ISC people. We're getting a lot of engagement on that. Go ahead.
Yeah, so I left my cane in the Badia, whatever. I kind of say half agree, half disagree with Mark on that. So I would say there is a big problem of attention spans dwindling, but I wouldn't necessarily say the problem is the attention spans of the students. And sometimes it might well be the attention span of the PIs. And I know I have worked in... have I worked already? The States, for a little bit in China, I worked a little in Germany, worked in Poland, worked in the UK now, and you always end up having some people who actually know what they're doing, some people who don't know what they're doing but they're willing to learn, and some people who basically get told by their PIs, okay, here is your GPU, here is PyTorch, around this I expect results in 3 months. And then they end up asking questions. So yeah, of course they don't know what they're doing and they end up asking stupid questions, but it's not that they really, it's not that they choose not to have the attention span, they just simply haven't got time to think about it.
Yeah, I'm going to indulge the panel and go back to this topic because a lot of what we've heard is the kids these days problem. They just don't have the attention span, they just won't learn. Is that really the problem, or are we teaching the wrong things here?
Well, many years ago, I asked Steve Koonin a question around these lines of PIs, and he paused and he responded with, ignore the faculty. So I think, you know, if you go to your faculty advisor for advice on how to code, you better hope that they know what they're doing. But if they don't, that's okay. The internet exists. You can learn these things. Like, curious kids can solve a lot of problems. And faculty, the best thing that we can hope for is that faculty don't stand in the way. But the point of getting a PhD is to become an independent scientist. And I think that the thing that we should encourage the most is for kids to be curious and to use whatever techniques they want. If they want to write in Julia and it makes their punch card programming boss feel bad, then that's fine.
Alexander, you've been wanting to get into this topic.
Oh, well. Okay, I mean, I came out of academia a few months ago, so I have some strong opinions. But in any case, I would formulate a more modern topic with ChatGPT. So there is this question now, at least in some European universities, that should we ban ChatGPT for students or not? Because now you have to give an exam and you have the programming question, and it's very easy that the students will just put it on ChatGPT and it will just pop up the code. And then do they really learn programming? And so this is an ongoing discussion. So I don't think I have the answer, but my intuition says that allow progress and just be more careful on what you teach and teach the students how to learn. So don't give them just the response, but as we did in the engineering faculty in Greece, where everything was open book, we just taught how to find information, not just to get fed the information.
Mark, you picked up your microphone. Go ahead.
Yep. So, by a slight digression, I must say well, first of all, I still think that all these large language models are severely overhyped at the moment, but I still absolutely love the fact that people who end up using them uncritically or not sufficiently critically in their work end up essentially sometimes dealing with those nonsense answers, hallucinations and whatnot, because essentially that's you would think computer is supposed to be deterministic and make sense and so on, but no, now the computer can lie to you as well. And me as a particle physicist by training, this uncertainty, undefined conditions, fuzziness, it's kind of nice to see this going more mainstream. But yeah, anyway.
All right, get him, Jeff.
Well, I think if ChatGPT could do the homework, ask interesting questions, right? As a peak chemist, I had to diagonalize a 3x3 matrix by hand because that was just a thing you had to learn how to do. Obviously, anything can diagonalize a 3x3 matrix. But you have to start with the idea. You have to say, can you prove that you understand why you diagonalize a 3x3 matrix? So the fact is, if ChatGPT could do 2D stencils or transpose or sorting or whatever, well, don't ask implement sorting as a homework question. Ask something like, given the following data set, produce the following analytics. And if sorting's part of that, say, sure, who cares? Use ChatGPT. But one, you better use the right sorting algorithm. Two, it actually better be syntactically and functionally correct, and then put the challenge on the design. Like when I do job interviews, right, I don't ask stupid questions like implement pancake sort in C, because if you don't use a standard library algorithm for sorting, you should be fired, right? That's, unless your job is to implement standard library sorting for a living, don't do that, right? So ask questions that require human brains, not lookup tables.
I love that answer, and I am just old enough to remember the tail end of a debate as to whether kids should ever be allowed to use a calculator in class, because no one would ever learn how to add and subtract ever again. And yet somehow we learned how to adopt this tool, and kids still learn how to add and subtract, but they also know when it's appropriate to use a calculator and why do we add and subtract. But since generative AI got invoked, before I lose you, Jeff, I want to ask this question, because it's been pointed out that whether it's HPC or AI are driving a lot of the same types of technologies. We need these high-performance processing elements at scale, but generative AI hasn't been around that long. So the question is, if you put your future hat on, because we're talking about future here, going into the future, does generative AI or machine learning still require HPC-like powerful computing technologies at scale into the future, or does that precipitate down and doesn't need the same level of computing power as we roll forward? And if it changes, what kind of time scale are we talking about?
Again, it's all linear algebra. So the answer is there's a huge amount of synergy and the bandwidth requirements and the throughput requirements. The one that I'm sad that I'm going to get booted and somebody else is going to have to deal with is, and maybe you should, we should get Horst up here and talk about LinPack, but the fundamental difference between simulation and AI is precision. That is sort of the filter now on where we are, where, as people have noted, NVIDIA is doing FP4 and joked about FP1 and exciting things like that are maybe not useful for physics. And then on the other hand, we have David Bailey, who's famous for proving why 64-bit isn't enough. The interesting thing for the mathematicians and the scientists and the algorithmicists is actually, do we have to choose? Because in my work in quantum chemistry, we proved you can actually do it all with single precision, or you can do it with multi-precision. Actually, Hatem does this stuff for a living. But I think the question of the math and the precision is the reconciliation of the architectural divergence that we think we see. I don't think there's a problem, but we need people to do math and do enough with the programming language and system support to make it so that somebody can get accurate results without necessarily having an IEEE 754 exception in hardware everywhere.
I'm sad I'm not going to hear what you think about LinPack. Thank you, Jeff. You can tell me later. When's Torsten going to get up here? Right now? Okay.
Okay.
All right, Torsten, you know the rules. Introduce yourself.
I know the rules. Well, I'm Torsten, obviously, from ETH Zurich. And yeah, I have to disagree with everybody, actually. That's going to be a long spiel, so I'm not allowed to give the long spiel, I guess. So first of all, I disagree with Kathy. She's probably already gone. Oh, she's still there. So on the AI front, I've actually seen the most amazing engineering in terms of optimization. I have seen people optimizing AI models. I think what you meant more or less is the broad community. But if you're training a $100 million model, you do some pretty amazing engineering to optimize that model. That kind of also addresses the Marco or Mark, I'm not 100% sure, question about what's the incentive? Well, the incentive is just monetary. And if you're at a small university, like the other chemist was mentioning, there are too many panelists. The other chemist was mentioning, trying to.
I got to keep track of them all up here.
Yeah, exactly. So it's about incentives, right? It's about if you're at a very small institution where you're spending only less than $5 million on your system, then who cares? Yeah, absolutely. If you're at a large institution like BASF, it's all I remember about you. So that of course you care, and it's the right thing to outsource it. And this is where I want to disagree with Rosa. And we don't necessarily need to educate the domain scientists to do all of that. I think the best way to do it from the domain scientist's point of view is to outsource these things to computer scientists, where I now want to disagree with Jeff, and we are coming to you. Where I now want to disagree with Jeff, actually, because now I lost my train of thought. Damn it! You shouldn't laugh that much. Okay, so yeah. And now I look kind of silly.
Cross-discipline teams, you were building off of that, and then you were going to disagree with Jeff next.
Yeah, cross-discipline teams. And see, it's hard to disagree with Jeff, as we learned earlier. So I'll leave
Everyone
it there.
Everyone agreed with Jeff the whole time.
Yeah, exactly. So I'll leave it there, and I'll get him back later.
All right, fair enough. Then jump on the other topic that we just said. Going into the future, does AI continue to drive scalable processing, high-performance processing elements, or is that not necessary over time?
Well, here's one thing where I disagree with you.
Okay.
You mentioned the AI.
I'm fair game.
Of course, the AI HPC thing, and I would say the question was ill-posed. You said, is AI going to consume HPC or not, or something like this? And I agree with Jeff here, unfortunately. I don't want to agree, it's not about Jeff. But AI is just another HPC workload. It has always been, and it will always...
Right, but that's the essence of my question, is does it remain an HPC workload?
Absolutely.
Does AI get to where it's not an HPC workload?
Absolutely, because by definition, anything that is about achieving highest performance on the largest machines on the planet that we have is called HPC. It's when we talk about high performance, I mean, it's a name, high performance computing. So AI, if anything it cares about performance is immediately high performance computing. So by definition, it's in there. And now the question is it going to be 99.9% of the workload? And basically, we could rename HPC.
All right, that's enough. Marek, what do you think?
Yeah, so I'm going to disagree with Torsten by beginning by agreeing with him in the sense that yes, right now this is still in lots of linear algebra and so on. So in fact, it's. Well, again, coming back from particle physics, you can basically always just scale the problem up to larger size, and then you need a larger machine. So I don't think this will ever going to, as long as we keep doing things this way, it's not going to stop being an HPC workload. However, cynical I might be, and I am quite cynical, I still have got this hope that we will actually see something new in computing, doing things some completely different way. It won't just be throwing numbers in the same way as usual. And I know, maybe it is going to be quantum, maybe it's going to be something else, maybe people start growing, living crystal into neural networks or something like that. One can dream, I mean. And I think I really hope that's something that a lot of us here, again, this is something I've heard before, I am inclined to agree. The HPC pool is quite high on the average age, and it's relatively small, but I really hope the younger people somewhere out there will do this thing, which I think it was Einstein who said that there are people who know it can't be done, then somebody comes who doesn't know it can't be done, and he does it.
Are too many people speaking on your behalf, Alexander? Would you like to speak for yourself?
And we'll hope we'll actually get to that point, we'll actually be able to...
I'm calling on Alexandra.
Yeah.
You see,
hope we'll stop being relevant.
You know, in HPC, always the same. So anyway, so I only wanted to note that yes, AI is still an HPC workload in my opinion, but we still need to go to exascale. When we in order to deal with trillion parameter models, we have to go to exascale, maybe post-exascale. Maybe then, since it is, I agree with Jeff, I think that it is still linear algebra, and then we can break down the problems, and so we will not need much more resources than that, but still I think we will need to scale to exascale.
We talked before about whether or not the future is GPUs. Another one we've talked about for the last 15 years is whether or not the future is cloud. How much of HPC and AI does it really make sense to run in the cloud? When is cloud the best choice? When is on-premises the best choice? And how do we make hybrid work? Do you want to start with that one?
Oh, so as a part of your HPC, I say that basically our user base is completely different. And for us, AI also is AI-infused applications. So we have a different problem and a different user base. So we deal also with, we don't monetize, let's say, our resources. So cloud is a bit prohibitive for some academics and some SMEs, and that's where we step in, and we have our supercomputers that in the future will be more specialized for AI, and SMEs and academia can have access to that. So I think this is the biggest difference.
All right, thank you very much, Alexandra. Eric, do you have someone new for us up here? You can come on up then.
You can always stand.
Will you stand behind the chair, or are you going to take a different one? Ah, disagreeing with the chairs right out of the gate. That is an innovative approach. All right, you've already got a prominent role at this conference, but rules are rules. Please introduce yourself.
And I need a microphone, correct?
Yes.
I'm Michaela Hoefler, University of Tennessee, Knoxville, and accidentally the program chair of ISC 2024.
Well, thank you very much, and I'm thrilled to be here at ISC, as I was describing. But the topic, you have to disagree with something next.
Okay, I disagree with something that I think has not been raised here.
Okay.
I disagree with my colleague who say that we cannot work with industry when it is about democratization of science.
Who said that?
Several colleagues. They are not here, unfortunately. But
okay.
There are this idea that industry have a different perspective, and they don't understand democratization of data, democratization of HPC. And I want to make a stand and say that we need to work with industry.
Well, you just dovetailed into the topic that was already on the table, because industry, relative to public sector, has a much higher penetration of cloud computing for HPC and AI. So what do you think about cloud and its role for HPC and AI?
I think it's important. I think we need to converge. I think that we need to create application that we don't need to rewrite them, but we need to rewrite the software layer that allow us to move our application from HPC to the cloud and vice versa.
All right, well, I'll double click then, because you're talking about cloud and integrating that, but you were also talking about democratization. How do we deal with where the data lives? On-prem, multi-cloud? Data locality has been an issue in HPC for years. Sounds like you just made that harder.
Well, it depends. We need to have software solution that allow us to reach the data where they are generated. We need to have seriously to think about where to put the data. We have been great with software repository. Now it's time we think about data repository. And it has not to be fragmented. It doesn't have to be silos, but we need to have concentration of data science and data repository that are open to people.
Torsten.
Okay, so cloud, to follow up with your original question about cloud and HPC, cloud is a business model. And it's just a business model. The hardware is exactly the same. There's absolutely no difference. Like in Azure, you can go and you can rent your favorite supercomputer, and that's it. It looks exactly like the supercomputers we have on-prem. Other companies may follow. It's really just a business model. And that gets us to the data question. I mean, data has been famously used to hold customers hostage, not only in the cloud.
Oh, you noticed?
Not only in the cloud, actually. There are also some HPC centers that I want to mention where it's quite hard to just claim there is no connection. So it's very important to be mindful of that. And I have no good solution for this. It's just an unfortunate observation that this is the case.
I will give you the case study right here. Remember when these things were free if you got a new cell phone contract, and now they cost, what, $700, $800, $1,000? Why? Is the camera that much better? No, it's because they forced me to use their cloud, right? And now the switching costs, the exit costs, if I want to put this down and get a different whatever, how do I bring all my stuff with me? That's how you're integrated, and I think that gets played out at the enterprise level now.
Yeah, pretty much. But the question is how to solve it. I mean, that's a very hard one because it is a business model question, and economics is much more complicated than HPC.
But on the other hand, if I may disagree, the question is also you cannot just go to look for federal funding that provide us with solutions. So the funding are limited, the resources are limited if we rely on taxpayer so what do? I mean, must be something in between. And industry have to come towards us because at the end of the day, the business model fail if they don't have a deliverable.
Marek, what do you think about cloud?
Okay, so this will be me talking with two different hats on, one as an HPC person, one as an open source developer. Okay. I love cloud as a technology stack. I love how much flexibility it gives you, what kind of things you can do with the cloud. I bloody hell the commercial cloud and this vendor locking and what you said, holding data hostage and intentionally, I will say that, making interfaces not incompatible. One can hope this adversarial interoperability thing that the EU is trying to push through will have some effect on that, but I'm not too hopeful about it working too well. Be like something we hear during this talk just a moment about this integrated system where, yeah, of course you can use this, use like a generic solution for accessing the GPUs/CPUs from different vendors, but if you want high performance, then you have to use the proprietary thing. But yeah, so ideally, I would absolutely love to have this everything in the cloud, there's everything be composed and everything. In practice, since we've got the vendor locking, this is not feasible. We do have to keep in mind that shoving terabytes of data around is going to cost a lot of energy, which is quite a problem as well. I mean,
yeah, I agree with that, and it's unfortunate that as an analyst, I've developed a reputation for being anti-cloud. I'm not. What I'm against is the idea that it will all go to cloud, or that everything is inherently better in cloud, or that cloud is automatically cheaper. I don't think any of those are true for HPC in particular. On the other hand, cloud soared through the pandemic because cloud is great at being flexible, a lot more so than on premises. And I think it's an outstanding sandbox for future technologies when I've got a lot of things that I have to evaluate.
May I disagree? Okay.
Yeah, sure.
Well, people do run things like hyper-converged infrastructure based on cloud solution on-prem. And you can kind of get the best of both worlds.
Torsten was about to disagree with me again.
Hyper-converged, what a word.
That's a buzzword I learned recently.
That's like detectors go off, like wee. So disagreeing with the whole cloud statement about being flexible, that's another one. I mean, I have used too many clouds where actually that was not very flexible. So if you exceed the size of a cluster, there is a physical system also in the cloud that has a limit. And these limits are actually not super large it depends on your customer grade. So you may not argue that you're more flexible, but what it's about at the end is a cloud. It may just give the opportunity to pool more resources. And a big computing center, like a national computing center in the United States, is probably also able, if there was a single one and not 15, to pool more resources. And this is the benefit of the cloud. It's a larger group of people. And then again, it's the business model.
I have to interrupt you long enough to thank Marek and let him sit down. Thank you very much.
Thanks. Well, can I...
Come on, Georg.
Well, Eric's got to find us someone, but go ahead and keep talking,
So
and Eric will
something
get us
that I
somebody.
feel is a little bit a misleading belief is that scientists need all their data, that when they access the data, wherever they are, they need to have everything then eventually in their laptop. It's not true. The majority of the scientists want to have the data in a safe place, and they want to be able to access them remotely, search what they really need, and most of the time is a small portion of that data, and move perhaps only that small portion. And so we need to go in that state of mind that is not all the data immediately, but is searching and the needed data remotely and moving only what is needed. And that impacts the business model. Because as long as we educate the scientists and we put the scientists in the condition of accessing only what they really need, that perhaps is a disruption of this business model of moving data to make money.
And I interrupted you before, Torsten. Do you want to finish your point?
The point, yeah. the point about the business model. Actually, I said economics is more important, more complicated than HPC, but in that particular case, it's not that super complicated, because at the end, the cloud provider is liable to the stock market, to the investors. This is what every cloud provider is the same. So if you're running a large system, you have to make enough profit to make your investors happy. That's actually quite a lot of margin that you need in order to make your investors happy today in the era of exploding stock prices. So this means fundamentally at the price point, a cloud provider is at a disadvantage with respect to a large data center provider. What I'm predicting is that the large data center providers who can actually run workloads at 95+% utilization over extended periods of time on larger machines, they will prevail. The small ones, they will have a problem, because the small ones, they will have two issues. So first of all, they don't have the economy of scale. They have to hire a system administrator who has a constant overhead on the system, I mean cost-wise, which is a huge problem. And the second problem with this is that they would actually, they don't get a good price for the hardware they're buying, and thus they're fundamentally not really competitive. And the third problem is the users may want larger systems, so they will teach them how to use to the cloud just for scaling, how to move to the cloud just for scaling. So the smaller ones may all die. The larger ones, like DOE style, will most likely survive.
Too big to fail.
It's not too big to fail. It's just the business model is different because they don't have to generate profit. Like, there's a huge difference between you, I'm expecting you to pay me a 10% dividend every year or stock price increase, versus I'm running a public institution, which may also be not the most efficient, but well, let's not talk about that here.
Bjorn, would you like to introduce yourself?
Yeah, I'm Björn Willenberg from GNS Systems. We make engineers happy. So we do we do consulting, plan, build, and run clusters for our customers. Usually engineers. We're in Germany, and we're also dealing with HPC systems and also with data management.
And what would you like to disagree with today?
Actually, I would like, so we do that on premises and also in the cloud. So especially me, I'm leading a team, small team, for cloud infrastructure. And especially for smaller customers, it's really useful to use the cloud. It depends on the workload. So when the workload is 90% or so, or the time, then it's good to have everything on-prem. But when there are peaks, then it makes absolutely makes a lot of sense to run it in the cloud.
All right, we've been talking about some of these very big companies. I'd like to go around to the smaller companies, for the smaller technology companies, because there's any number of new startups. We see a ton of them here, a lot of them rushing to AI, but we also talked earlier about industry consortia and the importance of these models. How does a smaller company that's got their own technology build an ecosystem around their product when they're going against the big guys? Torsten, do you want to start with that one?
I tend to help the big guys, you know. So I'm having a hard time defending the small companies. The problem with the small company is that if you go against the big guy in the big guy's field, you have basically no chance. And here I would follow Kathy's advice: if you can't beat them, join them. I think that's a very important advice. By the way, there's a Twitter poll still open where I posted Kathy's question to the community. Beat them or join them as an HPC community. Go vote on that poll because we want to see what the community thinks. Sorry for the plug.
So you're voting join them.
I cannot vote in my own Twitter poll though. But I think we should, but if I would have a vote, I would think we should join.
Torsten, it's really depressing what you are depicting here. There is no hope. What about specializations, finding specific type of data, specific type of application, specific community that have specific needs, rather than having everybody's happy and nobody's happy in a big company? What about addressing specific community? And there is where small company can find a niche.
Absolutely, but what I'm saying is that small company, like your company most likely, can provide a service on top of cloud providers. So there may be a common substrate that allows for specialization on top of it in terms of services and deployments like you just described, that is some kind of symbiosis between the two.
Yeah.
I'm not saying there is
parasitism.
Bjorn just got here. I want to hear what he has to think. You two have been talking a lot. You're talking about advising smaller companies who are on the user side. What would you advise the smaller company on the technology side? Can they bring their new technologies to market, or do they have to join them instead and you just go with the big guys? I'll put it in another way. Would you ever advise a small company to look at something that's maybe not one of the big standards and say, this is a better fit for what you're doing?
Usually I would take the technology which is well established, but I think it depends. So for, what was the question? Sorry.
The question was looking at some of the technology entrants, the smaller technology startups. What do they need in order to build their necessary ecosystems and get adoption in the market?
I think they should ask companies like us, and we can build the system for them.
Fair enough. You're going to solve the problem for them. Torsten, why don't you get out and make room for... We got to bring John Schalf up here, since a lot of this is his fault. Thank you, Torsten. All right, John, introduce yourself and disagree.
All right, so I'm John Schalf. I'm from Berkeley Lab, and I guess I'll start with, it's unfortunate that I have to disagree with Torsten now that he's not here to defend himself.
That's not unfortunate at all. He disagreed with me earlier.
Yeah, well, so first thing, I'm going to agree then followed by disagreeing about the cloud. It used to be, it was fairly generic, and it was very difficult to beat a data center that's 95% cycles consumed, because the average for the cloud is 30%, and that's up from 15% 10 years ago. However, I disagree with that the cloud only offers generic computing. In fact, in discussions with AWS, you're like, why do you keep trying to sell us GPU instances when you charge 10 times more than it costs to buy the things, even though they're not cheap? And they have, however, this data processing engine called Redshift, where they have full custom node architecture of their own design with the NVRAM in it, and it's an Oracle killer. It optimizes the queries, and it's hardware, software co-design, and it's a really amazing thing, and I don't think we could touch it with anything that we have in HPC. The second thing that I want to disagree with, what was this? There's something else that Torsten said that I was going to do.
I don't know.
Beat them or join them.
Oh, yeah, you're going to beat them instead?
No, and it's beat them, and both sides of the question we should pursue simultaneously. If there's anything that we got from Kathy's talk, was that it's all of the above. There isn't one path. You can't toss 100 years of algorithm development and say we're only going to do AI from now on. That's crazy. And you can also, there's multiple ways to take advantage of economies of scale, and buying an AI machine is one of them, but also joining with the hyperscalers and specialization is another. Both are on the table.
All right, well, here's where I want to go last then, because we're getting short on time on the panel, but I think it wraps up really well, because we've talked about the beat them versus join them. We've talked about industry consortia. We've talked about how do we start advancing new technologies, and we talked about what's hype and what's reality. So the question I'd like to set up for the panel at the end, and I'll start with you, Bjorn, is there a specific technology innovation you see out there that you think should be getting more attention, right? It's underhyped right now. Like all the hype is on something else, and you're like, what about this over here that's pretty great? What doesn't get enough hype for how good it is? You want to pass, let someone else go first?
I think.
What? Sorry, I didn't hear it up here. Fortran. Jeff's the leader on the points board right now, by the way. All right, go ahead, Bjorn. You knew you had to answer questions when you came up here, right?
It might indeed be the cloud with traditional companies because they try to avoid it and don't see the advantages.
Cloud doesn't get enough hype? No, I'm rejecting that one. Go ahead, John.
So I'll say chiplets, and yet they're very hyped, so it's hard to...
Not as much as cloud, all right, but you're a fan of chiplets.
Yeah, no, I think it's a way for us to work together with the cloud designers. I think Kathy pointed out that the cloud wants to sell us services, so we don't get to be inside. However, if you talk to the other side of the cloud, not the sales team, but the engineers, they all get together and they actually share across all of the hyperscalers interfaces and standards that enable them collectively to be more efficient. And that's what we're missing out on, because I don't see you guys there, and you should be.
All right, Bjorn, you picked up your microphone again. I'll get you in a second.
Maybe I found one point. It's about data management and
yes.
the idea how to transfer the data to the right location.
All right, you're back in my positive points column. I'll take that one. Go ahead, Michaela.
Well, let me tell you that if I had the right answer, I would not be here, but I would be on the exhibit floor with my startup.
Well, but to our earlier point, that can be hard. I like what Bjorn just said, though, about data management. I'll tell you a specific aspect of it I think is not getting enough attention is data tiering, right? It used to be we talked about tiered data. You had two tiers. You had disk, you had tape. That was what tiers were. Now you might, with flash and with on-node and with burst buffers and near archives and cloud, you might have 5, 6, 7 tiers.
You have to rephrase your question. It's not what technology, but what problem should have our attention.
All right, what problem should have our
data,
attention?
definitely data.
Data.
Big elephant in the room, nobody speak about, seems everybody are scared.
I'm pretty sure I've heard about data at this show, though.
A little bit, but not enough. We speak too much about AI, when AI is just a tool for data. But nobody speak about data.
I brought up storage on this panel last year, and it went crickets right down the panel. We had to go. That was the one topic I could not get anyone to engage on was data and storage last year.
It is scary.
John, what do you think? Problem that we ought to be talking more about?
Yeah, well, I mean, also data is what underpins our ability to exploit AI. And that seems to be underrepresented, that those people who have the more data are able to exploit AI better.
Bjorn, do you agree with all of this?
I would like to put some emphasis on one aspect of this. So the traditional HPC, as far as from my experience, always has a small amount of data for input and large output. And for AI training, it's completely the other way around. It's a lot of output, of input and a small output.
Well, I agree with that, and I'll tell you one thing I'm looking forward to at this show is I'm interested in conversations with people who are willing to talk to me about traditional modeling and simulation and not just AI. How does it work together? Remember, these things do come and go. 10 years ago, we talked about nothing but big data at this show, and now it's AI. But HPC endures because I don't think we're going to get to the end of science anytime soon. How are we going to carry this forward into next year's conference, Michaela?
By reinventing HPC.
I think we'll stop there. Please join me in thanking an excellent group of panelists. Kathy Yelick, Rosa Badia, Marco Kelling, Stephan Schenk, Jeff Hammond, Alexandra Krufali, Mark Zuba, Torsten Hoefler, Michaela Taufer, Bjorn Willenberg, and John Shelf. Thank you very much for being my willing panelists. And thank you for letting me moderate. ISC is really a special conference at the nexus of HPC for Europe and for the world. I am absolutely thrilled to be here again and so grateful to the organizers for letting us run this fishbowl panel again. Thank you very much and have a wonderful week.